Hello, everyone, and welcome along to SeptembRSE. This is day number 4. My name is Chris Edsall, and I will be chairing this session, which is presentation session number 2. We've got 3 talks today. I'll just remind everyone that this is being recorded and will be published on YouTube, and the entire conference is covered by the Society's Code of Conduct. In the session today, we'll be hearing later from Bob Turner about insights from Research Software Engineering Survey. Also, Malvika Sharan from the Alan Turing Institute on the Turing Way. And also, the talks will be 20 minutes. We'll have 5 minutes for questions. You can submit your questions on Slido. And I think what we'll do now is introduce the first speaker, who is Graham Lee from the University of Oxford. Has a fantastically titled talk about software engineering in industry. So take it away, Graham.
Thank you very much for that intro, Chris. I am going to do all the screen sharing stuff to get ready. I did consider staying muted for this bit so that you all covered for me under that panic, but now I'm ready, so I'm going to get started. So yes, I am a senior RSE in Oxford. I have some contact details, and this is about Clowntown, or what it's like writing software on the other side of the chasm. Now, what is the software chasm? Well, Diane Kelly wrote in 2007 that the scientific community isn't applying the current solutions offered by the software engineering community for whatever reason. And in her paper, what she was saying is that the sort of research software, or scientific computing world specifically, has particular problems that it is trying to solve using software. And the industry software engineers typically have other problems that might be related, might be completely unrelated, that they are trying to solve with software. And that for some reason, we've got these sort of general purpose, one size fits all processes, techniques, methodologies, and so on, that we apply to all of those things, and that it would be better, like it would more efficiently solve the specific problems that we have if software engineering experts, practitioners, researchers, and so on from the various fields started to analyze the differences and started to look at the domain-specific or application-specific techniques. Over time, I think that this has become a sort of motivating call in the research software engineering world and in e-science and things before that, but the interpretation has been different. Let's read the sentence again. The scientific community isn't applying the current solutions offered by the software engineering community for whatever reason. And I think that in the sort of later literature and in opinion pieces, and even in like a lot of the work that we do as RSEs, we've gone, oh, what we need to do is to apply the current solutions offered by the software engineering community for whatever reason. But without asking the question, why either do these things apply to what we're doing, or even do these things apply to what they're doing? How do we find out about these practices in software engineering? Typically from people who do them and whose projects succeeded, i.e. from the planes that come back. We're doing things that people have had not yet blow up in their faces, not necessarily things that are successful or are best practice. And so I want to look at what it looks like when you're writing software engineering, when you're doing software engineering in industry. And I want to use this idea that while the circus has left town, the clowns still remain, which is a Russian proverb, or at least there is an English proverb that there is a Russian proverb that says that. I haven't actually validated that. And the problem we have with understanding what practices, what techniques, what methodologies work in industry software engineering is that we can't actually evaluate the software. Software is a lemon market in the same way that used cars used to be. You used to go to a used car dealership, there would be a car, you could see its like nicely polished exterior, you could see a salesperson stood suspiciously still in front of the one patch of rust on that otherwise beautifully polished exterior, telling you how this was both a great car for going, hooning around the countryside on your own, and for taking your 4 children and dog in, and all of your luggage off on holiday. And the only information you had to go on was the information presented by the salesperson. Customers couldn't evaluate the products. And in a world of like software as a service, in a world of like prepackaged bundled apps delivered through an app store, customers can't evaluate the software they're using other than using the information that's given to them by the vendors or by buying it and trying it out for themselves. So we have this situation, even I would say for open source software. I challenge anyone who, like me, works on, say, in the JavaScript ecosystem with things like React, to actually read and critically understand all of the code in the node modules folder for one of your projects. I have certainly never done that. We're taking a lot on trust from the people upstream. And not only do the practices not always work and aren't reliable techniques for producing high quality software, but the people doing that understand that. And that's where this idea of Clowntown comes from. Now, Clowntown is an idea from Facebook. And if I say that, then I know that what's going to happen is someone is going to work out what the possible most negative interpretation of the phrase Clowntown is, and then tweet saying, Facebook obviously believe that, that most negative explanation, and that this is the next way in which they intend to undermine society, is by calling all software engineers clowns, or by taking up juggling, or whatever that interpretation is. Actually, within Facebook, Clowntown is quite a sort of mature and humble approach to software engineering. You never say that someone else's code is Clowntown. You say that my code is Clowntown, or that my team has done something clowny. You say that we have made a mistake that we now acknowledge. We are making that vulnerability, making that humility public by acknowledging that we made this mistake. And by sharing the fact that this mistake exists, we can now prepare to address it, or we can do the work that is needed to make things better. We are learning, we are growing, we are improving our capabilities. And the way that we do that is by understanding and building on our previous mistakes. So it would be wrong within Facebook for me to reject someone's code review by saying, this is Clowntown. It would be right for me to reject someone's code review saying there is a problem here, it doesn't appropriately identify the originating user, and for the author to go, haha, that's complete Clowntown, I'm sorry, I'll go and fix that. That's the way it works. And that's the spirit in which I want to share the examples that are coming up. Just as a trailer for another session, I've saved the juiciest example, which is a mistake that I made in a very big piece of enterprise software for the coding confessions session. So these are all things that I've been involved with that happened at companies that I worked with, but are not like the absolute hoolie of a mistake that's gone into coding confessions. So if you want to really understand how bad I am at software engineering, please come to coding confessions later in the month. So continuous integration is a best practice. And of course, Facebook have adopted continuous integration and continuous deployment to make sure that errors don't get into production. Only errors still get into production. This headline from 2019 describes the longest outage that Facebook have had to date, when everything, Facebook, Messenger, WhatsApp, Instagram, all went down for 11 hours. The previous record being 9 hours, and that was the one that I want to discuss because it's the one that I was involved with, because it happened at the time that I was working there. So like I said, we've got this deployment pipeline. We're using CI, we're running automated tests against all of the code changes. We're writing the tests, obviously, before they get run. So, a bunch of industry best practices being applied. One day, an intern was tasked with reconfiguring the databases on the production infrastructure, and they wrote not this, but something like this. For those who would like to see what the problem is, it's this third quotation mark on this line. This stops this file from being a JSON object and turns it into basically not a JSON object. Now, did this in turn make a mistake? Undoubtedly, but did the system and everybody else at Facebook allow that mistake to propagate? Certainly. So was the intern at fault? No. What they did was permitted by the text editor and by the tools that they have on their computer. It was also not picked up by their peers in code review. It was also not picked up by the integration pipeline or by the deployment pipeline. It was picked up by the database server, which so the production database servers noticed a configuration update, updated to it, and then stopped working because they couldn't pass the configuration. That's all right, because Facebook has a hot spare set of database servers. Basically, the infrastructure can notice that there's no database anymore and configure these other servers to take over. And the way it does that is to update their configuration to the latest version and then deploy it, at which point all of the hot spares fall over as well because the configuration is not valid. We're still all right because we've also got cold spares. So the data center can notice that none of these services are running, turn on some other computers, update their configuration to the latest, and then deploy them. Now you'll notice that we've basically replicated this whole problem across the entire infrastructure now, that every computer that could run the database is refusing to run the database. It doesn't actually take 9 hours or 11 hours to fix that. It takes 9 hours or 11 hours for everything else to realize that there is a database server it can connect to and to update itself and to get back to normal operation. So did we fire the intern? No, of course not. Yeah, they made an honest mistake. What we did was have an after incident review where we said what happened and what was the chain of events, what are the properties of the Facebook system that allow this very small problem, one character typo in a text file, to turn into a 9-hour-long production outage. And now what do we do in order to make the system resilient against that? What do we do to improve? But if you want a definition of a multi-hundred-billion-dollar company that is succeeding at software engineering, it's a company that allows a one character change in a text file to bring down its entire estate for 9 hours. You'll notice they didn't go out of business as a result of that error. Another company that didn't go out of business as a result of its error is a small consumer electronics company in Cupertino by the name of Apple. And this error is very well known in the information security community. All of the Python programmers on this session are now going, well, what's the problem? Because this is a problem that is related to the C programming language, which is what they were using. We'll notice that the fact that this failure exists means that we've probably adopted an industry best practice that we as research software engineers promote amongst researchers, amongst RSEs. We train it in software carpentries. We write about it in the Turing way, which we're going to hear about later on in this session. That is version control, because the only way that you ever get this bug into a software project like this is by resolving a merge in your version control tool badly and ending up with the same line of code written twice. But you'll also notice that we are adopting cutting edge best practices, like ignoring what Edgar Dijkstra said back in the 60s when he said actually Niklaus Wirth said go to statements considered harmful, but as the title for a letter that Dijkstra had written. So we've got this error check in the operating system's validation of SSL certificates, in its identification of the remote end of a network communication. If that error happens, then we want to bail out, go to the end of this function and report the error and basically stop doing anything further. If the error doesn't happen because of this mistake in the merge, we're also going to go to the end and report the error, only there is no error. So what we report is success. And so none of the other subsequent checks happen. And any malformed SSL certificate is accepted by the operating system and by every app and process running on the operating system. When I say the operating system, I mean Mac OS, iOS, iPad OS, tvOS, and watchOS. So basically like everything. This is, this is the sort of error that you can still get and still be a successful software company if you do get by following software engineering best practices. And yet, this is the kind of error that you could get if you were following those practices in the 1970s. If you were using C in the 1970s, if you were using RCS or SCCS as your version control tool in the 1970s, you could have had this error. Here we are, not quite 50 years later, because this is a historical incident. So 40 some years later, we can still introduce this error. This is the rate of change of practice in software engineering. Okay, so those are two sort of practice-related issues. Let's have a quick look at a project management-related issue. Now, what we all know is that software engineering best practice in industry is agile software methods. Are these evidence-based methods? Are they based on surveying entire industry and finding out what works, what doesn't, and then drawing theories from that? No, if you look at the start of the Agile manifesto, it says we are uncovering better ways to develop software by doing it and by helping others to do it. So this technique, which was published in 2001, but work was developed before that, the argumentation in favor of it is we're the experts, we think we should be doing it this way. And so far, we have done all right. And by the way, that was 20 years ago and we haven't moved on. So we were doing everything right in this particular company. We were engaging with our customer on a frequent basis. We were making sure that they were in charge of defining acceptance criteria for the work. We were encoding those acceptance criteria in automated tests, and then we were developing to those tests so that we knew when we delivered the next iteration of the software in 2 weeks' time, it did what the customer wanted. Unfortunately, the person we were talking to at the customer site was the person whose job it was to keep our relationship sweet. It wasn't the person who had to use the software. And this is a common practice in industry software engineering, is to build what the customer wants, not what the user wants, forgetting that those are different people. So when the user finally was permitted to use the software, which cost about £5 million to develop, they found that their productivity was 20% of what it was using the spreadsheet that they had built themselves. And a copy of Excel costs something like £100. So there's a 4 orders of magnitude increase in cost in using the custom software, which reduces your productivity by 80%. Go team, but nothing went wrong during the development of the software, either systemically or individually. We were following best practice, we were writing tests, we were using version control, we were doing continuous integration, we were making sure that the tests reflected what the customer wanted. Everything was golden from a industry software engineering practice perspective. And yet the thing that we were doing was building the wrong thing at great velocity. And what I want to sort of, I'm kind of just laughing at my own misfortune for 15 minutes here, but I want to have a message, and it is that when we say that we should be doing what the industry software engineers are doing, we're kind of taking a grass is greener perspective. Perhaps the fundamental reason that software engineering works the way it does in industry is that there is so much more money in software engineering in industry that you can survive your failures. That if you are Apple with trillions of dollars and you release software that can't validate a SSL certificate correctly, you still survive as Apple, and you still continue to write software in the way that you have learned. You won't go out of business if you follow. Now, because of our connection to research and our understanding of research methods and techniques, we're actually in a position not to follow industry, but to lead, because we can be the people who take a evidence-based approach. We can be the people who take a reflective approach, who use rational argumentation in defining the practices, in connecting the practices with the theory in a way that isn't happening in industry. So let's acknowledge that this chasm exists, but rather than trying to follow the people on the other side in the hope that we get the greener grass, let's lead the way. So there we go. Thank you very much for your time.
Thank you, Graham. And so I think what's going to happen is Christopher is going to share the Slido screen. And if you can paste into the chat the Slido URL. And given that both of those questions currently have 0 votes, we'll just take them in the order they appear on the screen. So Graham, is it good that we can see what doesn't work? Sorry, it is good that we can see what doesn't work, but what do you think we should be doing? What would work for research software development?
Yeah, that is the central question that I raised at the end, isn't it, really? Like I'm kind of saying that these things, I mean, they evidently work to some extent because these companies still exist and they persist, but they don't necessarily reflect the best way to develop software. They represent a satisfactory way to develop software. What I think we need to do is to connect, and this is what doesn't happen in industry in many organizations, is to connect software engineering practice through a collection of dotted lines to our goals, right? We need to say, on my group, we are trying to provide accurate weather forecasting 10 days out, or identify good drugs for this particular membrane interaction, or whatever it is. What are the things that we can do that make that better? Not what are the things that we can do that make our software better, because our software is merely an instrument for doing that other thing.
Cool. So if that's the goal, how would you educate our colleagues in research and academia that it's impossible to catch every bug?
Yeah, so I suppose that is the thing that the Agile techniques have done well at, is they've said, we acknowledge that we're not going to get everything done within the next 2 weeks, but we're also going to replan within 2 weeks. And so if it turns out that this thing is catastrophic, then that's what we're going to be fixing next. And how to so I've definitely seen in research projects that basically I think that Anonymous's question comes from the sort of the waterfall approach to thinking that comes from the way that research projects are funded, right? We've said we want this much money from the Research Council over the next X months in order to deliver this thing, and therefore we have to be done after X months with this thing working. And what we need to do is to encourage a bit more sort of iterative and risk-led thinking. Here's where we are now. Is it more important that we get down to 0 bugs on this, or is it more important that we develop in this other way? What is the thing that's going to get us again towards the goals of our research?
So there's a vote for the prolific Anonymous, another question of theirs. How do we best ask the research questions about what practices work better than others, and how do we design the studies? It seems like applying academic research to the process of research software engineering.
And it's exactly that. So I am at the end of the first year of a PhD on asking exactly that question. If you come back in 2 years, I will have a competent answer for you, hopefully, or I might have iterated towards something else, if I listen to my own ideas. So the approach that I want to use is an approach from the social sciences called grounded theory, where what we do is we look at what people are doing and we ask them what they're doing, and we we observe them, and we look at data like source code repositories, like bug tracking databases and so on, and use that to build a theory of what is going on at the moment and what people think about what is going on at the moment. Because then that tells us something about how the practices are actually spread. You know, we can all say industry engineers do TDD. What we know is that a vocal subset of industry engineers do TDD, and some of them we read their blogs, and then, you know, that's how we learn that. But what actually happens, and what and why do people think that actually happens? And then we can understand what the system currently is and how to nudge it in the ways that we would like.
Magnus asks, is it just a lack of resources? Should we be aiming for, you know, what they do in, you know, the level of quality that they do in industry, like say Microsoft Word as a product? So
is Microsoft a polished product, or are we polishing something that merely rhymes with Word? And the reason I ask is that Bill Gates, I think this was an interview in CT magazine, it was a German technology magazine in the early 90s, you know, saying, why are we why is Word so buggy? When are you going to fix all these bugs? And his response was, people don't pay for bug fixes, people pay for better features. So that's what we're going to deliver. We're going to deliver new features that excite customers to give us more money. I'm obviously paraphrasing, but like, you know, when we say polish, we mean satisfactory, we mean good enough, we mean that we know what the edge cases are in Word and we just sort of navigate around them. Do we lack resources in comparison with industry? Certainly. Like, there are plenty of people employed in the big Silicon Valley companies whose job is basically to not have a job at the competing company, and they're given a project to work on so that they don't have a project to work on at Google or at Netflix or wherever. Are those resources that allow for better software, or are they resources that allow for surviving adequate software? That's the question that I'm asking.
So thanks very much, Graham. I think we've run out of time for questions, so apologies to both Anonymouses and Drew. Really looking forward to the results of your research. It sounds fascinating.
Great, thank you. Yeah, like I say, come back in a few years.
We will. All right, we're going to move on to the next talk now. So Bob Turner from Sheffield is going to present the results of their software survey. So please share your screen and take it away, Bob.
Hi everyone. Can everybody see the slides and hear me and see me?
Yes to all of those. Yep.
Fantastic. That's great. So I'm going to talk today about some sort of operational research that we've done into research software and research software engineering at the University of Sheffield. So first of all, thank you all for coming and listening. Thanks to the conference organisers for having me, for choosing this talk. Thanks to the RSE team at the University of Sheffield, Paul Richmond in particular, who's our team lead, and he started this survey off and ran it. And then I got the data to kind of analyse and disseminate. So about me, I'm a research software engineer. My background is a mix of software engineering and academic research experience, about a decade of research experience, some private sector software engineering, and the past couple of years it's been research software engineering. And I work in the research software engineering team at the University of Sheffield. I'm not trying to sort of flex here with how big and impressive we are, because I'm sure there's more big and impressive entities out there. But we have about 13 RSEs in the team. Last year, we were involved in 35 projects, approximately worth about 11 million in total. And I kind of mentioned this because it seems big to me. And I feel like with a team this size, we kind of have the capacity and the responsibility to ask the sort of questions that I'm going to be looking at today. So why have we chosen to do a survey? We want to improve our practice and procedures as a team. So a team of this size, we have increasing numbers of sort of written procedures, how we handle scoping meetings at the start of projects, how we interact with people, what we do. So we want to be able to improve that and continuously improve that. most of the work that we do as a team is what we call cost recovered. So we have essentially we allocate proportions of our engineers' time to externally funded research projects, but we do have a little bit of resource that we can use more flexibly, and we want to be able to prioritize our resource use so we get the most out of that. And the other reason is to be able to advocate more effectively. So we're often advocating for the role of research software engineers and research software engineering, either to individual academics, the department, the university, government, and we want to be able to do that based on not just our ideology and our beliefs, but also on data. So that said, I'm personally quite scared of surveys. I'm not an expert surveyor. My research experience has been around sort of biophysics, and I could set up my experiments and make a single change to a system and look at what that does, what the effects of that are. So why am I scared of surveys? Well, I've got an example here of a survey question from the Art of Statistics by David Spiegelhalter, which I love, and I'll read it out. A survey would not be valid if the questions were biased in favor of a particular response. For example, in 2017, budget airline Ryanair announced that 92% of their passengers were satisfied with their flight experience. It turned out that their satisfaction survey only permitted the answers excellent, very good, fair, or okay. And the footnote's quite amusing as well. So we can see from this that the way in which we ask a question, so we're not going to, none of our questions are going to be like this, really, but we need to be very careful about how we ask the questions in order to get unbiased outputs. And it's also important to be aware that when we're going from the responses that people gave to the survey to making broad general conclusions about our target population, about the university as a whole, or maybe beyond, there's a number of kind of steps of inference that we have to get through. Does our data really reflect our sample? So what kind of biases have we introduced by the way in which we've asked the questions? Does the sample represent the study population? So the sample is a subset of everyone who could possibly have participated. And then, you know, are we doing something that is taking a sample that is representative of the broader population we want to talk about? So many notes of caution there, but I'm going to dive in anyway. So the sources for this, I've tried to follow good practice here. Really welcome feedback. I think we have some real experts, I suspect, in the audience here. So really welcome your feedback and questions. So you can go and have a look now at the data and the software that I've used to carry out the analysis. It's all on GitHub. It's on public repository. There's also a report that goes with this if you want to look at things in more detail, which is a PDF. So those links are there. I'll paste them in the chat if that helps at some point. So the survey itself is based on surveys carried out nationally and at the University of Southampton. It's kind of inspired by these. And in general, what we asked about was sort of sample demographics. And by demographics, I mean sort of who the funders were, what faculty people were in. We asked about use and development of software. We asked about training and about funding and staffing. Some general things to be aware of in the analysis. Oh, thanks, Mike. Some questions were optional, some were mandatory, so I've marked these where I'm showing a chart. The data was anonymized manually before it came into my hands. I cleaned it and annotated it using Python scripts with some manual decision-making needed to be made around the natural language that people used in some of their responses. Plotted the charts using Jupyter notebooks. This presentation and the report, which is work in progress, are written in Markdown. And then these outputs, what you're seeing here, are built using Pandoc and GitHub Actions. So every time I push commits to the repository on GitHub, it rebuilds. So hopefully this is reasonably good practice for dealing with the data and doing the analysis. So starting off by looking at the characteristics of the sample, it went out to all PhD students and research staff by email. The text of emails in that repository with a prize incentive. We had 382 responses. The Southampton survey has a benefit over what we were doing in that they sent the questions out on a per faculty basis. So they were able to say that they had a similar response rate for each of the faculties, which helps with the kind of chain of reasoning and generalizing the conclusions. And we weren't able to do that. In the national survey, I'm not clear on what the sampling strategy was. I'd be interested to find out more about that if I've just missed that information somewhere. So given what I've just said, and I don't know how many researchers we have in each faculty at Sheffield, it makes this generalization quite difficult. But what I can say is that the major faculties in the university that I would expect to have seen responses from are represented here. AMRC is the Advanced Manufacturing Research Centre, which is quite a big part of the university. It's kind of semi-independent. I'm surprised by the low proportion of responses from medicine, dentistry and health. I know that there's a lot of research done there. But as I say, we've got these major faculties represented at least. Similar picture for funding. I don't know what the proportions of research funding are to be able to kind of normalize this, but what I can see is that the major research councils and the major charities are represented within the responses here. So you can see those listed, although whether they should be in this sort of order or not on the basis of overall funding, I'm not sure. I think a similar thing I have to say about the jobs, the roles of the people who filled in the survey. So we capture a number of traditional academic research job titles and roles here, and that's all we can really say is that we've covered these. Whether we've covered them proportionately or not, I'm not sure. So on to the importance of research software, which is kind of thinking back to sort of why we're doing this. We see these sorts of numbers a lot when people are advocating for research software engineering, or I do anyway, so anecdotally, I guess. So when we asked, do people use research software, there was a definition in the survey, so it wasn't just left that vague. Vast majority of respondents do use research software. Many of them see it as being extremely important. When we look at software development practice and ask if people have developed their own research software, we see that a sort of subset of people have developed their own research software within our respondents. So sort of summarizing this and comparing it to some other results, we see in terms of use of software and importance of software, as far as we can tell, a similar picture at Sheffield to the national picture. So we can go ahead and sort of say, yeah, software is very important. This figure of how many people write their own code, I think for me is one of the most interesting things to explore with these surveys, because when I have conversations with academic researchers, they're often surprised by these figures, whatever they are. So yeah, I'm not entirely sure what to make of this at this point. Perhaps the University of Sheffield has a smaller proportion of people who write code than the national average, or perhaps there's some problem either with ours or with some other surveys, chain of inference, and that we could get a better estimate of these numbers. So the next thing that we looked at was training, or the next thing that I'm going to present is on training. And we asked whether people feel that they've had sufficient training to develop reliable software, and more people said they didn't feel that they've had sufficient training than did. And obviously this comes with problems around people assessing their own abilities and people's personal sort of internal biases about this. But it paints a picture that sufficient training has not been received. We also looked in more detail around some key skills and practices that were mentioned in the previous talk, and the charts are quite small here, but we found that there wasn't, I would say, there wasn't as much awareness as we would like to see around any of these skills, although it does seem like people are more confident with version control than with continuous integration and unit testing, and that's kind of encouraging because my personal opinion is probably the more important of those skills. We asked about current level of support for software development needs, and this is a particularly difficult question in terms of biases, I think, because different people will have different ideas of what's poor and what's excellent. The impression I get from looking at the data is, yeah, this is okay. I'm a bit worried that 12% of respondents said it was poor, which seems like something we should maybe do something about. So summing up on training, lots of people feel that they've not had enough training to develop reliable software, and the current level of support for software development at Sheffield is questionable, which is a responsibility that's shared between the RSE team and the IT services. So looking now at funding, so I get a bit confused with these percentages. I'll do my best to explain. We asked if we're kind of motivated by the idea that if people are writing research software, then it should be funded. It shouldn't be unfunded work. And so we asked whether people were applying for funding for research projects that involved writing software, and if they were they asking for money to do the software development? So lots of people don't expect to write software as part of the research projects, but the interesting thing is that the ones that did expect to write software, 40% didn't ask for funding to be able to do the software development work. And that also something I'll come back to in terms of the actions that we might take on the basis of this at the end. We asked about staffing of software development within University of Sheffield, and this was really contrasting the model of employing someone on a contract basis to do the development or to use someone from a pool, which is kind of what our team is about. And it seems that people don't think hiring contract developers is generally a suitable approach, and that in practice that doesn't happen a great deal. When we asked about the RSE pool approach, we see that quite a lot of people view that as being a good approach that might work for them. Quite a lot of people are saying that that wouldn't be suitable, and in a lot of situations, a lot of projects, it's not suitable, but I don't want that to be because of some misapprehension about how RSEs work or how our team works. So sort of wrapping up on staffing, the pool model seems to be preferable to people, which I think resonates with our experience of this. Some people see it, however, still see it as being unfavourable. So a couple of other additional things as we get towards the end here. I included this as a sort of remark on what happens when one leaves a free text field for people to write in. So we were asking about use of high performance computing, and we got the excellent response. I tried but couldn't figure out how to use it. Then I was advised it's probably faster just to use my own laptop rather than waiting for the queue on HPC. So there's quite interesting sort of qualitative bits that one can pull out of this. But in terms of the sort of quantitative answers, we see that, yes, some people, a chunk of our respondents do use high performance computing. Some of them don't need it. And then there's another sort of subpopulation here where they're not using it, but they might like to use it in the future. And that's something where we might be able to take some action. We asked a bit about licensing and commercialization, and the overall picture here is that the respondents were not particularly interested in commercializing their research software in general. It seemed like they weren't that interested in that. And I take that to mean that they need more support with making their outputs available under open licenses. So what actions might want to take. So in my days as a researcher, we might have stopped there, but the whole point of this as an RSE and as a manager of RSEs is to try and pull some actionable stuff out of it. Well, that's a large point of it anyway. So we're already doing this, providing more training around these key skills that we asked about. But I think we also need to investigate more, and I don't know whether this is a University of Sheffield thing or a more general thing. We want to investigate why people don't feel that they've had sufficient training. So is that because the training's bad? There isn't enough of it. We're not offering training on the right things. People can't afford it. They haven't got time to do it. So there's a whole bunch of other questions that this has provoked, and it would be interesting to see whether there are resources that I can go to or ways that I can unpack this further. And I think we also need to think with our colleagues in IT services, perhaps, about why people responded sort of less than brilliantly on the question about support for software development. Some more actions that we feel we need to take. So this is something we need to get better at Sheffield, and no other institutions do this better, or probably some do it worse. Support people with making their outputs, these really important, really valuable outputs, which are their research software outputs, more available, more accessible, and reusable. Look at, this is, again, I guess I'm falling into the trap of putting my own biases into the outputs here a little bit, but I feel it's really important we try and improve the accessibility of our HPC facilities and see if we could be doing better with that. Something that I will need to do is do better at advocating for researchers to include software development costs in their funding applications, because I feel that they should almost always be doing this. So finishing up here, what might we want to do in the future? What might I want to do in the future? There's a couple of things. So it's possible that we can go further with this data set. I might need to reach out to colleagues with more expertise in statistics than I have to sort of analyze based on various different subgroups, see if we can say things about, are there different needs, different practices in people who are funded by the Medical Research Council and the EPSRC, or different needs in the Faculty of Science to the Faculty of Engineering. So it's possible that it's likely that there's more that can be done with this data. And then the other thing that has sort of struck me through this, and I'd quite like to look at a little bit more if I can find a way to do it, is does the sort of national or international picture that we have around these questions need to be revisited at this point? And with that, I'll finish, and thank you again very much for listening.
Thank you, Bob. So we've got a short amount of time for Q&A. We've got a rather large number of 9 questions in Slido at the moment, so we might not get through them all, but we'll start. Sometimes, Anonymous asks, sometimes I see that researchers who write scripts don't view themselves as, quotes, writing their own code. Could this be why you had a lower percentage of software writers?
I would have to, I think, check back to it would be sensible for me to check back to the detail of that question. But yeah, we could have made the mistake, frankly, of not correctly defining what it means to be writing your own code. So yeah, that absolutely could be the case.
How do you fund software maintenance? So does the post-delivery maintenance factor into people's perception of the support that they receive?
Okay, so software maintenance, sustainability of research software is a huge challenge for the research community and the research software engineering community. So we effectively, that we're only beginning, I think, as researchers and research software engineers to come up with solutions for this. And you may be absolutely correct that those responses are a sort of expression of researchers' frustrations.
Anonymous also asks, when should researchers receive their training? Should it be at postgrad, undergrad, or even at school level? Or is what we're doing right now just in time, as they need it, when they need it? Is that okay? So when should we
So
train?
I would love to have a sort of evidence-based answer for this question. So I'd be keen to hear if evidence exists on this. Our sort of experience has been that it's really good to do a lot of it at the beginning of a PhD. But we have begun doing some stuff at undergraduate level as well. But yeah, it's a really good question. I think perhaps just in time, or just a little bit after time is not the best not the best approach.
So Anonymous asks about unexpected software. How often do people end up needing to write their own software when they do not expect it at application? I guess that's grant application time.
So I don't have an evidence-based answer for this. I would really like to have one, so I can answer on the basis of my experience and the team's experience. I think this happens quite a lot, and it creates enormous difficulties in terms of being able to fund that work, particularly with our team's funding model, for us to be able to help. So we can provide a bit of free at point of use support. But yeah, I'd really love to know the answer to that question.
And I guess the answer to the next question is going to be on a similar theme. Do you know why 1/3 of the respondents didn't think the pool model was suitable?
So sometimes it's not going to be suitable, and sometimes we'd advise people not to use it. So this would be if someone wanted, we tend to not want to allocate engineers above 50% on an individual project for sort of their own well-being, I guess, and development. So that is one idea. What I'm keen to do is make sure that this isn't that it isn't because they don't understand what it is, and I want to be clear that with researchers that we're not trying to build an empire of 1 million RSEs. We're trying to do something helpful for research in general. So I hope it's not through ineffective communication on part of our team.
Right, and I think we've got time for just one more question. So we'll take Anonymous's question on testing. A survey on regression testing / unit testing hits close to home. I feel RSEs care more about testing, much more than academics. Are there any insights from the survey on that? So you had the 3 charts, which said continuous version control was people were most comfortable with, then continuous integration and testing. Is testing that important for academics?
I think there's an evidence-based side to this and a sort of experiential answer. So from my experience, whenever I manage to convince academics, non sort of software engineering researchers, of the benefits of testing, there's kind of a runaway effect. They can end up absolutely loving it. In terms of insights from the survey, it would be possible, I think, to break down by job role what people's responses were to those questions, and if there were high enough numbers, we might be able to get an answer. I don't have it at the moment, but yeah, that's a really interesting additional thing that we could potentially do with the data. So thank you for that.
Right, and with that, I think we'll bring it to a close. Bob, presumably you'll be around for the rest of SeptembRSE if people are asking more questions about the survey. Thanks very much for presenting that. We've got one more talk left in the session. So Malvika from the Alan Turing Institute is going to talk to us about the Turing way. But first, we're going to have a quick comfort break if you want to get tea or coffee or stretch your legs, a glass of water or something, and we'll be back here in 5 minutes. So welcome back. For the last talk in this session this morning, we have Malvika Sharan from the Alan Turing Institute. As before, with all the talks, the question and answer session will be at the end, and Christopher has posted the Slido link in the chat if questions occur to you as we're going through. And I think Malvika is ready, so why don't you share your screen and start? Thanks.
Can you hear me?
We can hear you now, yeah.
Awesome. Thank you so much. Thank you so much for this wonderful session. I've been enjoying all the talks, and I hope this talk fits into following up on what we've been discussing so far. So I will be talking about the Turing Way project, how you can use its resources, and ways to get involved in building a guide to reproducible, ethical, and collaborative research. But before I tell you about it, I want to start by inviting you to join me in this short visualization exercise about you. Imagine you just got an email, a really exciting email. It starts with, of course, like all the official emails, hey, you are invited to join the research project that you really wanted to work on. Your first reaction is, yeah, that's amazing. And then you start looking up more about the project. Knowing how much you have to work, soon your motivation turns into an overwhelming feeling. Maybe some of you also start to feel like an imposter. This is because now you're more aware of what you need to know in order to work efficiently on this wonderful project. From project design to project development to real-world deployment. There's so much to learn. For example, if you're working in data-driven research, throughout the life cycle of your work, you will be required to make complex decisions from project design to model development to system-level deployment. These processes involve multiple steps, from designing project for collaboration, effective project management, to identifying what data is needed or how the model testing and training will be performed, to ensuring ethical integrity so that when your research outcome is adopted in real world, you know how to assess the impact and what approaches you will take to do an iterative improvement. And that is indeed overwhelming. And therefore, I'm here to remind you, you're not alone in this process. Nobody should have to execute such complex tasks alone. Building an inclusive and collaborative research is not only helpful for individuals like you who are joining the project, but your participation is crucial to ensuring diversity of skills, interests, and perspective to build something that is greater than what anyone can do alone. Therefore, if we can join a new project within a collaborative research environment and find support from other researchers from the wider open science community, we can be confident to learn new skills while being appreciated for the knowledge we bring into the project. This is where now I'd like to introduce you to the Turing Way, which provides best practices, recommendations, and guidance to help you design your project for reproducibility. With the help of computational tools, methods, and collaborative practices completed with the ethical research. The Turing Way is an open source project that involves and supports its diverse community in making data science reproducible, ethical, collaborative, and inclusive for everyone. We believe that to make our project truly beneficial and comprehensible for as many people as possible, we need to collaborate with people with diverse skills, backgrounds, lived experiences, and domain knowledge. It is a part of the Alan Turing Institute, which is the National Institute for Data Science and Artificial Intelligence in the UK. And it is developed under the research program called Tools, Practices, and Systems. The core value of this program is to embed best practices across Turing research and team, as well as deliver trustworthy system, transparent reporting, inclusive interoperable design, ethical integrity, respectful co-creation, and leadership in open research. The Turing Way sits across most of these goals and provides a central resource for good practices to all our researchers within the UK and internationally. It was started as a book on reproducibility by Kirsty Whitaker, who is the project lead. Shared as a lightly opinionated guide, this book provides reproducible tools and practices to help ensure that the researchers, funders, policymakers, and all different stakeholders in research know what their responsibility of reproducibility is, what they can do, where they can make an impact, how they can make their work more efficient and understandable. So let me define reproducibility for you as we define in the Turing way. It is when same analysis is applied to the same data, it should give same result. There are other concepts around reproducibility like replicability, when same analysis is applied to different data or experiment in different conditions. And there are robustness and generalizability as well. However, reproducibility in computational analysis should be maintained as a minimum criteria to ensure quality and integrity of our research. It starts right when you have a research idea that you want to work on. You want to communicate that with others, plan and design your research. Then you will describe your protocols and collect data sets. Then you start processing and wrangling your data, conducting your study and analysis, publishing your data and other research components so everybody else can access it. Then comes archiving that can ensure that your data is reusable, meaning that someone else can go through this whole process of reproducing or building upon your work. Again, that's quite overwhelming. With this definition, the project started with the contributors who documented best practices, guidance, and recommendation in chapters describing concepts and tools that can ensure reproducibility aspect of data research. These chapters include topics such as open research, version control, licensing, data management, code testing, reviewing, continuous integration, and so on. We also provide the guide for project design. And the guide for project design is probably for people who don't really know where to start. If you don't really know what computational tool you can use, you would probably not look for it. So project design starts with an overview of project design where you can actually look at what stage of project you are in and what kind of consideration of reproducibility you should make. And we also talk about how to create project repository within research software engineering or in simple projects. We also discuss persona and pathways and different conventions in coding. In the guide for communication, with the help of Emma Karoun, we have been able to develop chapters on, for example, writing blogs for research communication, lay summary, podcast, presenting posters and talks and social media, as well as making research code site table, where we also discuss ORCID and Zenodo and other sort of services that you can use, and as well as communication of open source projects. We also have a guide for collaboration. We think that collaboration is actually quite a complex thing. It just doesn't happen by itself. So you need to be intentional when you're planning your collaboration. So we do talk a lot about GitHub or Git-based collaboration, but we also talk about how you can manage or build in your community within your project, what kind of leadership we see in data science. Because of all the knowledge that we have accumulated in the last 1.5 years around remote collaboration, we've also written a lot around what tools exist, how you can chair a meeting, how you can organize a conference, and so on. And finally, shared ownership in open source project. That's something I truly believe that when we contribute to an open source project, we should have a shared ownership and understanding of that. And this is something that we have explored in this chapter. So over the last 2.5 years, we have been able to write over 180 chapters, multiple community resources to ensure that people who are new to the project know where to start, what kind of training that they can access. And also we invite contribution directly on GitHub. So all our discussions and collaboration happen on GitHub. We have about 285 direct contributors there, but we also have lots of other materials and other events under development. So we use Zenodo quite a lot. So my talk is already on Zenodo if you want to download. You would see that I'm using a lot of illustration in this particular talk. I always use a lot of illustration in the talk, and those are also available under CC BY license, have been downloaded over 6,000 times and so on. And we also maintain our social media presence on Twitter, on Slack, and we have monthly newsletter in order to ensure that people who are not already in the project can get to learn about the project and actually use it in their work. So with that background, I want to highlight the guide for ethical research. The aim of this guide is to support data scientists and researchers to work in an ethical way. We start from the position that as researchers in data science, we have an obligation to consider ethical standards and their impact on society. At any stage of our project lifecycle, we have a duty to ensure that our work meets the highest scientific standards. We also have an obligation to ensure that our work maintains the highest level of moral integrity, especially when it impacts people's lives. This impact on lives can be through the processes we build in conducting the research, data we collect and use, and through the data products we build for others. It can also be through the policies that we follow in our organization and the working conditions that we create for others in our teams. So far, the guide for ethical research, we have chapters introducing the main concepts, case studies on working with the Institutional Ethics Board, and ethics in preclinical research. But we don't see ethics as a static or one-off part of the research process. Ethical research includes recognizing where your data comes from and the impact of collecting and using it in your work. Therefore, we explore relationships between ethics, law, policy, and human rights, and discuss activism and internal policy advocacy as well. I would like to acknowledge Laura Carter, Ismael Carerbi Garcia, Ariel Bennett, and Laura Asion, who are the core contributors of this guide and have mentored many new contributors in developing and reviewing resources. I want to emphasize that when we discuss ethical data research, we should be making sure that our work is grounded within existing human rights framework. There needs to be a wider shared understanding of what human right means across different countries, culture, and groups of people. This means that we create opportunities to listen to everyone about what being able to enjoy their human right means to them and make sure that research complies with human right. And this is where we want people to come into the guide for ethical research and share their experiences and perspective. Specifically, Laura Carter has written a chapter explaining the relationship between ethics, law, policy, and human right. And it comes with a disclaimer that the Turing Way guide is not a legal advice, that there are numerous accountability and enforcement mechanisms that exist within human rights framework. But because they are legal framework, they're not easy to access or very hard to understand or even hard to apply on our daily work. And this is where ethical guidance and codes can allow us to interpret and implement human rights in our work. The guide to ethical research also includes information on how to be an activist researcher. One of our most recent chapters is on how to advocate for policy change within your institution. If you don't like how something is done, you can work towards changing it. We recognize that ethical research includes treating our colleagues and collaborators well and apply inclusive approaches in how we establish collaboration and acknowledge other people's work. The guide to ethical research includes chapters on advocacy and unions, authored and mentored by Ariel Bennett and Laura Carter. They discuss resources for workers' rights for scientists and employees in research organizations, as well as information about how you can join and support the union yourself. Finally, there's a chapter being developed by Nina Dikara with her discussions with other researchers and contributors that aim to encourage people to build a habit of self-reflection on ethical research practices. She quotes Donna Haraway's paper describing how view from nowhere will be ideal to interpret data studies. But realistically, our lived experiences, including our culture, education, upbringing, as well as experiences of oppression and success, influence the way we do research. So in the Turing way, every little contribution counts. We foster a culture of collaboration by ensuring that the collaboration is not defined just by the common goals, products, or the team, but we also take time to make sure that people are given inclusive workspace that they need to perform their best, that they treat each other kindly, abide by code of conduct, know what roles they can take, and contribute to building diverse teams by explicitly opening ideas for contributions. In all our work, we apply open leadership principle to ensure that our resources are built to improve understanding, sharing, and participation in data science. So if you're interested, and I would like to invite you to take on any of these pathways to collaboration and become part of the Turing way. You can help us develop and share your knowledge in the project. You can help us maintain and improve what we already have, help us share resources. And because data science is so agile, it actually changes and evolves quite frequently. And therefore, anything that we write will go out of practice very quickly. And therefore, the project is always a work in progress. We also have different community members who are translating the chapters in the languages that are more accessible for their community, such as Chinese, Spanish, and French. And we, in general, invite any sort of best practices that you find useful for your research to be addressed in the Turing way. So I also want to acknowledge that this is a lot of work, and this is a lot of hidden work. Because we don't write author's name on the chapter to ensure that there is no psychological barrier for new contributors to come into the chapter and improve it. But we also want to highlight all these work that you will do. And it is very important to me that if we want to represent different perspective, we make sure that there are pathways for people to feel acknowledged. So we use a dedicated page. We have a policy on acknowledgement to make sure that everyone who writes into the book are given authorship of the book. So for example, these contributors record, where you can see an example of Batul Al-Marzouk, who's a bioinformatician in Saudi Arabia, but she's an infrastructure maintainer for the Turing way. And outside her work, she's developing her profile as a research software engineer. We also use all contributors bot. That is something that I would really recommend anyone to use it if they're using GitHub. All contributors bot allows you to acknowledge people even when they don't push code. So you can see in this particular example, Batul and Martina were working on something on the GitHub, but they had a chat with 3 people outside their work, which was Laura Sion, Sam Gay, and Yo. And they mentioned them in their discussion. And as a result of that, we could also acknowledge their work. So it's not just about what you do in the repository, but the kind of interaction you have with the people. So that was a lot. So I want to put it in perspective. The Turing Way is a book with 5 guides, which is always a work in progress. It's a community where people come together to collaboratively write chapters, build and maintain resources, share their skills and ideas around best practices in data science and research. We apply open source principle in development and maintenance of the project. And finally, it's built on the culture of collaboration, which is the process and the backbone of our project. I also want to pitch a panel that we are hosting in SeptembRSE on 28th of September. Officially, the nomination have closed, but because I am the person maintaining that nomination, I invite you to please take a moment to invite someone, to nominate someone who you want to acknowledge as a missing narrative in RSE. So this is basically a panel where we want to make sure that our diversity and inclusion discussions are not secluded to one topic that we already know about, but we also create opportunity for people who are not already here. So if you can go to bit.ly/Turing Way, you will find this as one of the first announcements. So none of this can happen without the help and contribution of our community members. So I'm really highly grateful to all the things that you do and they do in order to make sure that our work is not defined within a small geographic location, but we are actually trying to make global data science. So if you are interested, please take some moment to look into the resource and find the gaps and challenge what we have done there and help us with your lived experiences. So if you would like to join us, please feel welcome, and I would share more information how you can do that. But if you are wondering still, what can I do in this community? So you can learn a new skill, you can share a new skill, you can collaborate with others, you can mentor other contribution, you can find a mentor within the community, and you can represent this community into your work if you want to promote best practices. We value all sort of participation. Another pitch on a book dash. It's a collaborative event that I'll be hosting in November with the help of a community, with the help of our planning committee. It's a 4 days event, but you just have to attend 1 or 2 short sessions, which are 2 hours long. The application is open until 1st October, and all the information are also given in the bit.ly/Turing way, which is right here. There are all other ways to join us. There are collaboration cafes, co-working calls, community calls that are starting in October. And in general, because it's an open source, I want you to take ownership of this project and help us improve it in a way that it serves you. So with that, I would like to acknowledge Kirsty Whitaker for starting this project and all the community members, friends, and collaborators of the Turing Way. And thank you for listening to me.
Thank you very much for presenting, Malvika. The Turing Way is a brilliant resource. We've got a couple of questions in Slido, so we'll work 5 questions so far, so we'll work through those. Have you worked with funders to match up the recommendations to what the funders mandate? How do researchers know whose guidelines to follow?
Yeah, it's a really good question, because of course funders across different fronts have different requirements. So we have worked closely with the Turing training team, who have funding calls on training, in principle, what they want to promote in skill building and capacity building. We also work with another group, which is called Data Study Group, and we have curated chapters to make sure that people who join their study group know what is their starting point. We haven't formally worked with UKRI, but last year UKRI was using the Turing Way as an example of the research culture that they wanted to inspire through some of the funding call. But I think this question is nudging me to actually create the evidence base and probably connect with some of the funders directly.
The next one seems like a controversial question and could take up all the rest of the time if we let it.
Yeah.
What is the difference between a data scientist and a research software engineer?
I think it's a preference of people who are doing the research. So I'm going to say that because in Turing, we have a research engineering group, and people who join that group, they can decide if they want to be called research data scientist or research software engineer. And I think it is really about, where do you want your career to progress? Do you want to become a researcher and data specialist, or you would like to develop more engineering profile and probably move on to somewhat similar roles? So I don't think there is, in principle, a lot of difference. It's really about personal choice and what you like to be called.
Okay, Joaquin, I'm sorry if I mispronounced that. Joaquin asks, reproducibility requires data sharing, but some of the researchers with whom we work don't want to share their data. What do you recommend to do about this?
Yeah, it's a very good question, because I feel that data sharing and openness can be sometimes be confused as same thing. So a lot of time when you work within a team, of course, you need access to data. But if you're working with other teams, and if that team is working with sensitive data, it's their right not to share it with you. However, if you're working in a situation that the data access is very important and that is not possible, maybe a solution could be to help them build a model data. That could be a dummy data set, or just something that helps you test your model. And I think this question isn't about that. I think this question is about the personal apprehension, is that this is my data and I don't want to give you, because I want to get something really brilliant from that. And I have experienced that in my PhD time. You can't do much about it except that you do your work as openly and as accessibly as possible, so they feel inspired by it. If you are creating environment for them to come in as an equal stakeholder of your research, where they are not feeling subordinate, as in they don't feel like that they are being told what to do. If their opinions are invited into the research, I'm sure they would see the value of sharing.
So what examples have you seen of data being reused by a separate group at a time after the original project? So I guess success of the Turing Way, that would be.
Yeah, so a lot of time. I mean, I would say my PhD work is completely built on someone else's data, because I was working with lab researchers, and the work that they were doing wasn't yet ready to be published. So we were working on Salmonella, but E. coli is another data set that was available, and I could actually publish my software by showing and benchmarking my software against this data. So that's my personal story, that public data is extremely, extremely useful. COVID is an example. All the data within COVID are being published online, and that is allowing people to build models and reuse those data. So I think data publication, I've seen lots in practice. And I think entire machine learning is built on that idea. All the products that GitHub actually builds is built on free data that they have within GitHub. So I think, unless I'm misunderstanding, I think reuse of data is just very prevalent.
And the next question, I think, just asks the same thing, but about quantitatively. So there were stats for contributors to the Turing way on GitHub.
Yeah.
Do you know how many users you have applying the approach?
Yeah, so so I'm going to give a couple of examples. We have one group where we collaborate with. It's eScience Center in Netherlands. They are a group of research software engineers, and instead of creating their own internal guide, they actually contribute to the Turing way as a guide that they could use in their work. So of course they work in multiple projects, and in all the projects they want to maintain standards and process of reproducibility, and that's our like gold standard, that this is what we want. We want people to take the Turing way and make it what they want to use. We also have a group leader from Argentina who actually uses the Turing way as a way to teach her students what they want to apply in their research. So they go and read a chapter and come and talk as if it's a journal club, and they go back and apply it to their work. So quite a lot of people who apply to work in the Turing way are working in the Turing way because they want their groups to use it. So it's not something that they're building beyond their own work.
Right, we've reached the top of the hour, so I think we will call it a day there. Joaquin's thing is a statement, not a question. So Malvika, presumably you're also going to be around for the month of SeptembRSE?
Yes, I am around. I'm hopefully available on Twitter and everywhere. Just tag me wherever you want.
Cool, thank you. So that ends the session this morning. We've got networking in GatherTown, so please, if you can access that and want to, have a wander around, talk to people who you run into, make like this is a real physical conference in person. And later on this afternoon, the session will be a discussion, industrial software development practices. Do they work in academia? Should RSEs learn and use them? That's at 2 p.m. British time, and people involved there are Jeremy Carver, Ian Cotton, Colin Venters, Ryan Pepper, and Mark Woodbridge. So please do join us again at 2 o'clock this afternoon if you can. Thanks.